Great, so this week we're going to start off with section 4.3, which is on a little bit more with rational functions. We're going to also look at inequalities, not just equations. We'll also do a little bit with asymptotes and behavior model, same kind of stuff we did last week. We're going to look at trying to solve things algebraically and graphically. So if you have your calculator, we'll use that in a little bit. Right. First problem we're going to do has to do with this formula, D equals RT. Okay, I labeled what R stands for. You can see it. Does anybody know what the other two stand for?
Time and distance.
Yeah, time and distance. Right? In all the problems we do, we're going to assume that our rate isn't changing. So like if we're driving somewhere or traveling on a train, we're going to assume the speed stays the same the whole time. No acceleration or deceleration, just same speed all the time. That'll make it a little easier. All right, so distance equals rate times time. All right, so in this problem it says Sue drove 30 miles to a train station. Okay, at that point she got on a train and then completed her trip. In all she traveled 120 miles. Okay, we don't know how fast the car or the train was going, but we know the average rate of the train was 20 miles per hour faster than the car. Okay, so we have a relationship between the speeds, but we don't know the exact speeds. Okay, I want to find an equation that represents this. All right? And what I want to try to figure out is how long is it going to take her to complete her trip. So we'll come up with an expression. It'll have a variable in it, since we don't know the speeds of the train or the car. And then what we can do is either plug in a speed and find out how long it would take her, or we can say she completed her trip in an hour. How fast did she drive? And how fast was the train? All right, so if you view this as kind of like different legs of her journey, how many different modes of transportation is she taking? Two. Right, so to find the total time it's going to take her to travel, we have to find the time it takes her both in her car and then the time on the train. Okay, so total time equals time in car plus the time she spends on the train. Now, how do you find time if you know speeds and distances? How do you find the time if you know rates and distances? Yep.
Distance divided by rate.
Yeah, take the distance and divide by rate, and that gives you time. All right? So we'll just put that down here. Distance divided by rate gives me time. So I need to find the distance she traveled in the car and the rate she was going at in the car. Then I need to find the distance she traveled on the train and the speed she was going at on the train. Okay, so let's start with the time in the car. Distance. How much distance did she travel in the car?
30 miles.
30 miles. And now, what does it say to use for her speed in the car? It doesn't give us a number, but it does tell us what letter to use.
20 minus something, 80. Yeah, because the train's still 20. Okay, I'm not going to talk.
Right, you could think of it as something minus 20, and that's not wrong. You can do it that way.
Okay.
They're just having you look at it the other way. They're looking at it as like an x plus 20, but we'll get to that part in a second. How did they say to just represent the speed of the car?
X.
X.
Oh, I didn't see that.
Okay? We're going to find the time it takes where x is the speed of the car. So now how much time did she spend on the train? Well, find the distance the train traveled divided by the speed. What's the distance that the train traveled? Yep.
90 miles.
90. Okay, she traveled 30 in the car. The trip was 120. So total distance is 90. And now what's the speed of the train? Yep. Yeah, so we're going to look at it as a x plus 20 rather than something minus 20. Okay, so there's your t of x. Time as a function of x. Hey, any questions on that equation? We're going to use that equation for the next problem, then we'll do some other stuff, but then we'll come back to it. All right. Next thing they want is the basic stuff we've been doing, end behavior, asymptotes, and the roots, or zeros. All right, let's start off with the asymptotes. Okay, how do you find vertical asymptotes? Remember that? It's where, yeah?
It's where x
that would be your y-intercept. Like if you fill in 0 for x, that would be your y-intercept, which we could find. They're just not asking for it here. But I do agree x equals 0 is an asymptote. But how come, Ben?
It makes the denominator equal 0.
Yeah, find what makes your denominators equal to 0. So the first one, it's x equals 0. Brad, can you give me the second one?
Negative 20.
Negative 20. Now, in this particular problem, I don't think these asymptotes are particularly helpful because we don't have negative speed. All right, horizontal asymptotes. Okay, to do that, we got to find our end behavior model. Right, so end behavior model basically means we're going to look at the highest degree term in the top and the bottom of the fraction, but I really need to put these together. Okay, so my common denominator, it's just a product of the two that I have. X plus 20. Hey, Corey, what would I multiply top and bottom by to give the first fraction this common denominator? Yeah, multiply by x plus 20 over x plus 20. Okay. And now that's going to give me 30x plus 600. Okay, and the other one, Shannon, what would I multiply top and bottom by here to make the common denominator of x plus 20?
X.
Yeah, this denominator is just missing x. X. Right, so now I combine them together. So I get 120x plus 600 over x squared plus 20x. Okay, Brad, what's the highest degree term in the top? 120x. Highest degree term in the bottom, Steph?
X squared.
X squared. Okay, reduce that. That x is gone, that x is gone. There's my end behavior model. Now let x get really, really big and tell me what that approaches. Okay. What happens as x gets really big in that fraction? We approach 0. Okay, so we got our vertical asymptotes, horizontal asymptotes, end behavior model. Last thing we need is the zeros. Okay, to find your zeros, that's when you fill in 0 for y. Okay? Set your equation equal to y. This time it also helps to have it all combined together. DJ, what's the only way this fraction could ever equal 0?
Is it the denominator not being I'm not sure.
You want to help him out? What's the only way that something a fraction can ever equal 0? Cool?
Numerator 0?
Yeah, if the numerator is 0. Right, so let's set the numerator equal to 0 and see what happens. So we get 0 equals 120x plus 600. Okay. Bring the 600 to the other side. And last step, divide by 120. Okay, what's x?
5.
Negative 5. So negative 5 is the value you could plug in and get 0 for y. Again, negative speed probably doesn't make sense in this problem, but that's what it is. That's your root, or your 0. Right, now, what do these asymptotes mean in terms of our word problem? Especially this n behavior asymptote. As x gets really, really big, y approaches 0. Well, what's x and what's y? And why does that make sense? As x gets really, really big, y approaches 0.
Y be time and x be the speed.
Mm-hmm. So why does that make sense? Can you explain what that is?
The speed gets really, really high. The time we get closer to 0 it takes less time if you're going at a faster rate.
Yeah. So as the speed gets really, really big, the time it takes to get where you're going goes down and eventually approaches 0, but never reaches it. Because obviously there's always some distance between you and where you're going, and it takes some amount of time to get there. All right. So last thing they want is a graph. Okay, I'm going to go back to the original to graph it. So we're going to type 30 over x. We're going to need the graph to do something in a second. Over 90 divided by x plus 20. X plus 20. All right, for a window, let's just look at what happens if she drives at 10 miles an hour. Okay, it would take her 6 hours to do this trip. All right, so I don't think we need to look above 10. Unless she's driving really slow. If she's driving 1/10 of a mile per hour, it's going to take her a few days to make that trip, 304 hours. So we know it's going up very quickly. Okay, you got a vertical asymptote at 0. Negative speed we don't need to look at. Maximum speed, let's just go up to say 75. Time won't be negative. And let's just go up to 10. Okay, so there's a graph of her time to complete the trip depending on speed. Right, any questions on that? Right, and you can see it's kind of starting to level out. So the faster she goes, going a little bit faster doesn't start to make much of a difference. Like if she goes, say, 65, it's going to take her 1.5 hours versus goes 75, goes from 1.5 to 1.3. That's only 2/10 of an hour difference, which is like 2/10 of an hour is 12 minutes. So just going 10 miles per hour faster doesn't make a big difference when she's already going 65. But it makes a huge difference if she's going slow. If she goes 10 miles an hour, it takes her 6 hours. If she goes 20 miles an hour, she just cuts several hours off her time. Right? So it makes more of a difference at the slow speeds than it does at higher speeds. Right, so there's a complete graph. Any question on that? All right, so next part, they want us to find out if she has 2 hours to complete her trip. What speed must she travel at in her car? Okay, so she has 2 hours to complete her trip. Would that get plugged in for x or for y? Shelby?
Y.
Y, yes. Y is your speed, X, Y is your time, X is your speed. So I'm going to fill in 2 on the left-hand side, and I'm going to use the simplified version. 120x plus 600 over x squared plus 20x. All right, so to solve that, first thing I want to do is get this denominator on the other side. All right, so on the right, we've divided by it. Tom, how would I undo dividing by this denominator and put it on the other side?
Multiply.
Yeah, we're going to multiply by it. So on the left, I'm going to write 2 times x squared plus 20x equals 120x plus 600. Okay, Heaven, what could I do next on the left? Yeah, multiply out the 2. And DJ, what does that give me?
Gives you 2x squared,
Yep, 2x squared plus
40x.
40x. Okay, now this is turning into a quadratic. So generally, Olivia, when I solve a quadratic, what number do I try to get it equal to on one side?
0.
Yeah, we're going to get it equal to 0. So how could I move those other 2 terms to the other side? Yeah, just subtract them. So you got minus 120x and minus the 600. Okay, Madison, anything I can combine there? Yeah, what's 40 take away 120? Go ahead. So negative 80x minus 600. Now, if you were going to factor this, what you could do is factor a 2 out from each one of these, but it doesn't factor. All right, so if we can't factor it, how else can we solve it? Yeah, just use the quadratic formula. All right, so in this case, A is 2, B is negative 80, C is negative 600. Does anybody need me to go through the quadratic formula? How you do it? Okay. So the 2 answers you get are 20 plus 10 square root 7. And you also get x equals 20 minus 10 square root 7. Now there's only one speed she can travel at. Yeah, it's got to be a positive speed. This one comes out negative. So we cross that one out. Okay, so there's her speed. Right. Since we're going to, I'm going to do it graphically next. Let's just change it to a decimal so we know what we're looking for when we graph it. Okay, there's the square root of 7 times 10 plus 20. So she's got to go about 46.46. All right, so now the same thing graphically. Okay. There's the graph of her time. What do I have to do to find it graphically if it takes 2 hours? Yeah?
You could graph 2, y equals 2,
Graph y equals 2.
and then intersect.
Yeah, and see where they intersect. Okay, and hopefully it's 46.46. And this time we get 46.46. Okay. Any question on that? Yeah.
How did you get the 46 before you grabbed?
This one?
Yeah.
Oh, this part I looked it up in the book. Yeah, so from this point, you'd use quadratic formula. And that's the answer you'll get. Just plug in 2 for A, negative 80 for B, and negative 600 for C.
But if you actually like solve it out, like, would you get the 46.46 from the quadratic answer?
Yep. If you rounded it off, yep. So in the book they give you the exact answer, but if you type in what they got and round it off, you do get 46.46. Yep.
So is that an average speed?
That's an average speed, yeah. So the way we can look at this is assume her speed never changes. And I guess it's an instantaneous transfer from her car to the train.
Teleportation.
Yeah. There's no time from when she gets out of her car to when she starts moving on the train.
And no acceleration even.
She just parks her car on.
And there's no acceleration, yeah. So if we included all those things, it would just make it a lot more complex. I guess the only thing we could do that would be simple is say it took 5 minutes to walk from where she parked her car to the train. Then we could just add 5 minutes to the time.
Well, how long would it take her to like get the card and then get on the train to go?
And then the train
I feel like it would
catches
take a lot
up to
longer.
46 miles an
Yeah,
hour.
yeah, it would take a little while. All right, but any questions on this hypothetical speed of 46.46?
Hypothetically.
All right, so when we solved this equation, okay, way back at the first step, we multiplied both sides by something that had variables in it, okay, which you can do, but what can happen is you can get answers that aren't actually answers. Okay, you get these extra answers, okay, and there's a name for them. Okay, does anybody remember what those are called? Yeah?
Extraneous.
Yeah, extraneous solutions. All right, so anytime you multiply both sides of an equation by something with variables, you can get answers that are solutions to your new equation, but they don't actually solve the original problem. So what do you have to do? Check your answers. Okay, make sure they work. Here's another example. Equation x minus 1 equals 0. Okay, what's the answer to x minus 1 equals 0? Yeah.
X equals 1.
Yeah, it's just x equals 1. That's the only solution. It's the only number you can subtract 1 from and get 0. Okay, but let's say I take and multiply both sides of that equation by x. So if I do that, I would get this. X squared minus x equals 0. Just multiplied everything by x. Okay. Now on the left side, I could factor out an x. And write it as x times x minus 1 equals 0. And now I still get x equals 1 as a solution. But what about here? I get x equals 0. Both of these numbers, when you plug them into this equation, give you 0 as an answer. But does 0 work in the original problem? No. So by multiplying both sides by x, I introduced an extra answer that doesn't work. So I have to check it. Okay. Yes?
So will our test be on Friday or will it be on Thursday?
Friday. Yeah.
Because we have you on Friday, right?
Okay, so any questions on that idea of an extraneous solution? All right. So we're going to use that idea to solve this problem. We're going to solve it. We're going to end up multiplying by something that has a variable in it. So we're going to make sure we check for any extraneous solutions. Generally, with this kind of problem, an extraneous solution causes you to divide by 0. So after we finish solving this whole thing, if we get 3 as an answer, or 1 as an answer, we can't use those. Either one of those numbers I just said would cause us to divide by 0. All right. Did anybody notice a connection between the two denominators on the left and the one on the right?
1 plus
on the left are just the factors of
What
the
did you just say?
Yeah, the denominator on the left are the factors of the one on the right.
Are you okay?
But I agree, 1 plus 3 is 4. So what we want to do here is multiply everything by the same thing. So we're going to get rid of these fractions. We're not going to try to find a common denominator. We're going to try to wipe the denominators right out. Right? Here's another problem that a little simpler, but same idea. 2x over 3 plus 1 over 4 equals 2 over 12. And you know what? Think of 12 as 3 times 4. It's the product of the other two denominators. What number could you multiply everything by here to cancel every denominator out? Well, 0, but yeah, that would wipe everything out.
Yeah.
We don't want to do that.
Well, that's what you said.
Then we can't get an answer. I want to cancel the denominators out, not the whole problem. Yeah.
Do you go from the first equation to the second equation?
Yeah.
Oh, this is just a simpler example for what I'm about to do.
Okay.
Yeah.
I was lost.
Yeah. So what would I multiply everything by here to get rid of my denominators?
Is it only one number?
Mm-hmm. Yeah.
12.
Yeah. Multiply everything by 12. Okay. And I want you to, I'm going to write it like this. Multiply that by 12, that times 12, and that times 12.
Wait, why are you writing 3.4 then?
3 times 4.
Oh.
Yeah. Now, in the first fraction, okay, look what's going to happen. A 3 and a 3. So part of the factor canceled out. Here, 4 and 4. Okay, so now these two denominators are gone. And here, the whole thing is gone. That's exactly what's going to happen up here. Except what we're going to do it's going to have letters in it. Okay, it's not just going to be numbers. Okay, but same idea. Okay, just going to move that down. All right, so what could I multiply everything by here to get rid of all these denominators? Shelby?
X squared minus 4x plus 3.
Yep. Instead of thinking of it that way, though, I'm going to write it as x minus 1, x minus 3. Just like I wrote 12 as 4 and 3. Right? So we got x minus 1, x minus 3. X minus 1, x minus 3. X minus 1, x minus 3. All right. Now, part of that is going to cancel out everywhere, and then on the right, it's going to completely cancel out. Andrew, what part cancels out in the first fraction?
X minus 1.
Yep, x minus 1. X minus 1 is gone. Okay. Second fraction. Graham?
X minus 3.
X minus 3. That's gone. Okay, what about on the right-hand side? What cancels out there?
I got this.
Yeah.
All. Well, X minus 1 and.
Yeah, the 2 is there, but this is gone, and that's gone. Okay, so let's write what we've got left. We've got 2x. Okay, x minus 3, keep that in parentheses. Plus 1. X minus 1 equals 2. Okay, now we just have to distribute it out. We have a quadratic equation which we can factor or use the formula. I think this one factors. All right, so we're going to get 2x squared minus 6x plus x minus 1. And if we're going to try to factor it, what number should I get it equal to? All right, so I'll do that at the same time. Okay, Olivia, can you combine my like terms for me on the left and tell me what I get?
2x squared minus 5x
Minus 3. Right, and let's see if we can factor. So we're going to have 2x and x. Okay, negative constant, negative constant, negative middle. So my signs have to be, yep, negative and positive. Okay, let's try it that way. And now two numbers that multiply to give me 3, well, 1 and 3. So should I try 1, 3 or 3, 1? Yeah, 1 and 3 I think is going to work. 2x squared minus 6 plus 1 is minus 5. Okay, so we're good. Okay, when I solve the second factor, set it equal to 0. Matthias, what would make this 0?
3.
Yep. X equals 3. And Corey, what would make this 0? Close. Yeah, minus 1 and then divide by 2. Negative a half. All right. Now, what do I have to do with these answers? Yeah, check them, make sure they're not extraneous. I told you two numbers to watch out for when we started. 3. Can I plug 3 back into the original? No. If I did, I'd be dividing by 0. That one is extraneous. Okay, could we plug in negative a half? Yes, that would be fine. All right. So we don't actually have to check it. Just make sure it doesn't give you 0 in the denominator. Okay, so this is the only solution. X equals negative a half. Okay, so there's 3 cases that can happen. This is one of them. One answer works, one doesn't. They could both work, or they could both not work. So on the test, I'm going to have you solve one like this. If you forget to cross out the answer that's extraneous, I'm going to take a point off. Okay, so if you get this far and don't cross it out, you'll lose 1 point. So just make sure you cross it out. Yep.
So this equation is just to solve it by the...
Yeah. Okay, I'll graph it because it says to solve graphically. I'm not going to do them all graphically, but I'll show you we can get the same thing as a graph. Yep.
So if they were both extraneous, would you just not be able to solve the problem?
You just write no solution. Yep. No solution. All right, so this one was it 2x over x minus 1? Okay, and sometimes when you type in fractions, you got to put the denominator in parentheses, so I'm gonna do it like that. Okay, 2x over x minus 1 plus 1 divided by x minus 3. Divide by x minus 3. And now there's 2 ways I can do it. Either put this other side in y2 and find an intersect, or subtract it and calculate a root. I'm just going to find an intersect. Okay, 2 divided by x squared minus 4x plus 3. Okay, and where should these graphs cross? Yeah, you already know the answer. Should, if we did everything correct and I typed everything in, just our window. All right, let's go with zoom 6. Okay, so we've seen that kind of graph before in 3 sections. All right, and let's go second. Calc intersect.
So really you wouldn't have to do all that work, all you have to do is graph and find the intersect.
If they said solve graphically, yeah. If they said solve algebraically, then yeah, you got to do it. Negative 0.5. Okay, so this gives you a quick way to check your answer.
Just say graphically every time.
Can I say graphically every time? No, not every time.
Wait, so do they never intersect together?
No, these are asymptotes. Okay, so it kind of looks like they're crossing, but they're not. They're just getting very, very, very close. Okay, same thing down here. You might think they're crossing, but they're not. They're just very close. Okay, and then the extraneous solution was what, at 3? Well, they couldn't cross at 3 because watch what happens if I type in 3. Error. We're dividing by 0. So there's no way they could cross at a value that's undefined. It doesn't exist. Okay, so negative a half is the only solution.
Right.
This one, same type as the last one step easier because they already put everything on one side. It's already equal to 0. Do we have the same pattern where this is just the product of those two?
Yes.
Yep. Then all we got to do is multiply everything by x plus 2. Okay. And that's going to cancel all our fractions out. All right, so parentheses, x plus 2, x plus 2, x plus 2. Okay, one thing to be careful of is if you have a minus sign. Okay, that minus, this sign, goes with that number. So I'm going to be distributing a 3x in a minute. If that was a minus, what would I be distributing? A negative 3x, and people always mess that up. All right. So remember, you distribute that number along with the sign that's in front. Okay. All right. First one, Heaven, what cancels out here? Yep, x is gone. Okay. DJ, what's going to cancel out over here? X plus 2. And last one, everything cancels out except the numerator. Okay, so we're going to be left with x squared. Okay, I'm going to distribute it out. Plus 2 minus 3 minus x minus 6. Plus, distribute the plus and the 3 to the x. So plus 3x plus 6x. Combine our like terms. Okay, I get 9x, take away x, which is 8x minus 6 equals 0. Okay, any questions so far? All right. So let's make sure we get everything here. So we got x squared plus 2x minus 3x is minus x minus 6. That's good. Plus 3x plus 6x. All right, so here, made a mistake. That x also cancels. So it's just a plus 6. So now what we can do is minus 6 plus 6. That cancels out. So now I just get x squared plus 2x. Now we're good. Okay, because the constant canceled out, we don't need to factor it. I mean, we don't need to use quadratic formula. What can I factor out of the left-hand side? X. And what does that leave me with? So Steph, what would make this first factor 0?
0.
Yep, 0. And the second factor, Shelby? Negative 2. Okay, let's go back to the beginning. Could we plug 0 in for x? Nope, that would be a divide by 0. Could we plug in negative 2 for x here? Nope, that'd be negative 2 plus 2, that'd be 0. This is one like Corey asked me about, no solution. Can't solve this one. Right, and the third case, which we're not going to do one, is they both work. Okay, questions on that? All right. Okay, so this problem kind of takes us into the last thing we're going to do in section 4.3. Okay, when you read that over, what's different about this kind of problem than everything we've done so far? There's a phrase in there that makes this different. Yeah? Less than. Yeah, so before we were doing equations. Less than is what? That's an inequality. Okay, so now we're going to start looking at inequalities. Okay, this one, though, we're not going to use algebra. We could use a sign chart. We'll try one like that in a minute. But we're just going to graph it. All right, so it says, at what rates would Sue have to travel to make her time less than 2.5 hours? Okay, so that we want her time to be less than. And what was our original equation? 30
30
over x
plus 90
over x plus 20. Okay, just plug that in. I would put this in y1 and put that in y2. Okay, let's see what we got. All right, so we got 2.5 and 30 over x. In this case, I don't think I needed the double parentheses, but in this one, I will just to be safe. 90 over x plus 20. Oh, thank you. Division sign right there. All right, so we'll graph it and see what happens. Okay, we got to set our window back the way we had it. Okay, I think we went up to like 75 miles an hour. Okay, and what's the first thing I got to find? Kind of, it's the same step as solving an equation. Find the intersect. Okay, so they intersect at 34.88. Okay, so how do I write my answer?
Equals less than 34.8.
Yeah, x, what is it?
Less than 34.8.
No, greater than. Right? Or should be greater than.
Yeah, it should
Well,
feel like that.
I should be greater, so you have to
Yeah.
do this.
It is a little confusing if you read the problem. It says they want her time to be less than, but you actually use greater than in the final answer. Okay, because if her speed went below this, what's going to happen to her time as it starts going up? So we basically want to know, when is she in this section? Right? So anytime her speed is faster than 34.88, her time will be under the blue line, 2.5 hours. Okay, so solving an inequality graphically, pretty straightforward. Okay, when we graph it, always make sure you look for hidden behavior. I don't think there was anything there that was hidden, so nothing we really had to zoom in on. And when we do it algebraically, we have to do a sign chart. Why can't I solve it algebraically just the way I did with an equation? Multiply both sides by something with a variable. Think about what happens when you multiply with an inequality and what you have to be careful of. But if we're using variables, things could get a little confusing.
There's another where, like, if you divide by a negative, you can swap a sign or.
Yeah. So the problem is, if you multiply or divide both sides by a variable, we don't know if the variable is positive or negative. That's a problem because we don't know if we should flip the sign. All right, so when you're solving an inequality, do not multiply both sides by something with a variable because you don't know if you should flip the sign. Use a sign chart. Okay, so we're going to try to solve this one. But does anybody remember from the sign chart method what number? You have to have it by itself on one side. Well, this one has 1, but
0.
yeah, you got to have 0. Okay? You have to have 0 by itself on one side. Okay, so first thing I'm going to do is put everything on one side. How would I move the 1 to the other side? Subtract it. And I'm going to write it as a fraction. 1 over 1, less than 0. Now, can I just take these two fractions and just say, oh, -1 minus 1 is -9? Just combine them together. Brad? Can I combine these two fractions together?
Yeah.
Okay, I can, but I can't the way they're written. Like,
You need a common
yeah, I need a common denominator. Okay? And my common denominator, the easiest way to find it is just take the product of the two I have, and that's my common denominator. Right, so Andrew, what's my common denominator here?
Wait, say that again? I was writing.
So the easiest way to find the common denominator is just take the two you have and multiply them together.
Oh, okay, so you have
And this one's a 1, so.
2x squared plus 4x minus 2.
Yep. So I'm going to multiply top and bottom. 2x squared plus 5x minus 3. Okay, so what I really have here is 2x squared plus 5x minus 3 over 2x squared plus 5x minus 3. That's 1. Okay, so put down our common denominator. 2x squared plus 5x minus 3. Now, the fraction on the left, it's already got the common denominator. So all that stuff stays the same. Okay, fraction on the right, we're going to multiply the numerator by our common denominator. In this case, not much is going to happen. I'm just distributing a 1. Well, actually, be careful. That negative goes with the 1. Okay, that's a mistake people make. Distribute the negative with the 1. So what will I get?
2x squared minus 5x plus 3.
And it's kind of nice that we got a negative 2x squared, because that's going to cancel positive 2x squared. Now I don't have any x squareds in the top. I'm not going to have to factor this. It's already going to be factored. 6x, take away 5x, is x. And negative 8 plus 3 gives me negative 5. Okay, so I have a linear factor in the top. And now the bottom has to factor. If we can't factor it, can't use the sign chart. Okay, so try 2x and x. We're going to need a plus 3 and a minus 1. That gives me 6, take away 1. We're good. All right. So now we've put everything on one side. We factored it. And now we're going to make a number line for each factor. X minus 5. 2x minus 1. X plus 3. Okay. What value would make this first factor 0? 5. What if I plug in numbers smaller than 5? Would I get negatives or positives in this factor? Negatives. Okay. What would make my second factor 0? Half? Negative, positive. And what would make my third factor 0? Negative 3. Numbers smaller than negative 3 would give me? Yep. Bigger than negative 3? Positive. So now we can make our final number line. We've got negative 3, 1/2, and 5 not to scale. So it's the sign is going to alternate in each section. Bless you. Okay, top one. Smaller than negative 3, what kind of number? So we have a negative. Top is a negative. Now the bottom. Smaller than negative 3. Negative. And then in the last one, smaller than negative 3. Okay. What's negative times negative? Positive. And what's a negative over a positive? It's a negative. So now the next section should be positive. We'll check it. Okay, between -3.5. Top one, between -3.5. Negative. Between -3.5 and between -3.5 on the positive section. Negative times positive is negative. Negative divided by negative, positive. Right, now we can tell where we're going to be above and below 0. In this case, they want below 0. So we're going to have two intervals. How would we write this first interval? From what to what?
From -infinity to -3.
Including -3 or not?
No.
Not including. Yep, or from
1/2 to 5.
those are the regions where we come out negative. Okay, questions on? Okay, so this idea we've done before. Right, and last one we'll do graphically. Okay, so my suggestion, how I would do it, put that in y1, put that in y2, and then see where y1 is above y2. Or the other way you can do it is bring 15 to the other side, get it greater than 0, and calculate a root instead of an intersection. Either way is about the same amount of work. All right, so we've got, let's see, x to the 4th minus 3x cubed. Minus 3x cubed plus 2x squared plus 2. Okay, and divide by x minus 2. What's going to happen in this problem when x is 2? Vertical asymptote. So keep that idea in mind when we answer this question. Okay, again, you're going to look for where the blue is above the red. Okay, since I have to go up to 15, let's do the standard window, except set the y max. Yeah, it could go up 20. Okay, and we're not seeing anything that's below. I think there is, if we were to look, there's probably some stuff we could see happening below the x-axis. Okay, but this part we don't even care about. We only care about when that blue graph is above 15. All right, so what do I have to do to find where it's above 15? Yep. Yep, let's find both of these intersects. So we'll start with that one. So second calc, intersect. Okay, and now for my guess, I got to make sure I'm closer to the one I want. Looks like it's 2.67. Pretty close, but usually the cursor highlights the intersection that you just found. So let me do that again. So pick a point on the blue curve, pick a point on the red line, and do our guess. All right, to me it looks like it's getting the one that's further to the right. So what I'm going to do, I'm going to zoom in. I think it's so close on the screen I can't get them separated. Okay, let's try it. Intersect. Pick a point on each curve and do the guess. Okay, so that's better. 2.67 0.22, comma 15. Does anybody remember what the other one was? It was 2.67?
Something.
That's fine, 2.67. That's the one it kept giving me even though I didn't want that one first. All right, so now how would I write where I'm above 15? Keep in mind, above 15 is anywhere, I'll do it in blue. That's just going to keep going, and that's going to keep going.
From infinity to 2.22. No, negative infinity.
No, we can't go all the way from negative infinity because
There's an asymptote. Oh wait,
from the asymptote, yeah.
From positive to
Yep, from positive 2, we're way up at infinity,
2.2.
and we're coming down all the way to 2.22.
Okay.
Okay, and it does say greater than or equal, so we can include it. Or, okay, we go down below 2 for a little while, and then from where?
2.667
To
to infinity.
infinity. And we can include it up to infinity. Okay, so a little tricky looking at the graph, but I think it's this type a lot easier to graph than to use algebra, if we even could. I don't think we could factor that nicely. Maybe there's some things you could do with it, but this one we're just going to graph. Any questions on that? All right, so the homework. It's really just 1 through 17 odd. 20 to 22, all. And then 24, 28, 31, and 32. Okay, so we'll take a look at that tomorrow. We got one more section in chapter 4 to do, and then that's it for chapter 4.